Neural networks are machine learning models that mimic the complex functions of the human brain. These models consist of interconnected nodes or neurons that process data, learn patterns, and enable tasks such as pattern recognition and decision-making. A neural network is a system or hardware that is designed to operate like a human brain. Let's get started. Neural networks are a type of deep learning, which is a machine learning process that uses a layered structure of interconnected nodes. They are able to solve complex problems that are difficult for traditional computer algorithms to handle. Warren McCulloch and Walter Pitts, researchers at the University of Chicago, first proposed neural networks in 1943. Their model, called the McCulloch-Pitts neurons, has evolved over time, but remains a standard. They modeled a simple neural network using electrical circuits to describe how neurons in the brain might work. For example, you've probably already been using neural networks on a daily basis. When you ask your mobile assistant to perform a search for you, say, Google or Siri or Amazon Web, or use a self-driving car, these are all neural network driven. Computer games also use neural networks on the back end as part of the game system and how it adjusts to the players, and so do map applications in processing map images and helping you find the quickest way to get to your destination. Neural network architecture. A neural network is usually described as having different layers. The first layer is the input layer. It picks up the input signals and passes them to the next layer. The next layer does all kinds of calculations and feature extractions. It's called the hidden layer. Often, there will be more than one hidden layer. And finally, there's an output layer, which delivers the final result. How neural network works. Each neuron represents a unit of computation that takes in a set of inputs, performs a set of calculations, and produces an output that is passed on to the next layer. Just like the neurons in our brains, each node in a neural network receives input, processes it, and passes the output on to the next node. As the data moves through the network, the connections between the nodes are strengthened or weakened, depending on the patterns in the data. This allows the network to learn from the data and make predictions or decisions based on what it has learned. Imagine a 28 by 28 grid, where a number is drawn in such a way that some pixels are darker than others. By identifying the brighter pixels, we can decipher the number that was written on the grid. This grid serves as the input for a neural network. The rows of the grid are arranged in a horizontal 1D array, which is then transformed into a vertical array, forming the first layer of neurons. Just like this. In the case of the first layer, each neuron corresponds to a single pixel in the input image, and the value inside each neuron represents the activation or intensity of that pixel. The input layer of a neural network is responsible for taking in the raw data, in this case, an image, and transforming it into a format that can be processed by the rest of the network. In this case, we have 28 by 28 input pixels, which gives us a total of 784 neurons in the input layer. Each neuron will have an activation value of either 0 or 1, depending on whether the corresponding pixel in the input image is black or white, respectively. The output layer of the neural network consists of 10 neurons in this case, each of which represents a possible output class, in this case, the digits 0 through 9. The output of each neuron in the output layer represents the probability that the input image belongs to that particular class. The highest probability value determines the predicted class for that input image. Neural networks algorithms. Feedforward networks. Multilayer perceptron. Convolutional neural network. Recurrent neural network. Long short-term memory. Feedforward neural networks. A feedforward neural network is a simple artificial neural network architecture in which data moves from input to output in a single direction. Multilayer perceptron. Multilayer perceptron is a type of feedforward neural network with 3 or more layers, including an input layer, 1 or more hidden layers, and an output layer. It uses nonlinear activation functions. Convolutional neural network. A convolutional neural network is a specialized artificial neural network designed for image processing. It employs convolutional layers to automatically learn hierarchical features from input images, enabling effective image recognition and classification. Recurrent neural network. An artificial neural network type intended for sequential data processing is called a recurrent neural network. It is appropriate for applications where contextual dependencies are critical, such as time series prediction and natural language processing, since it makes use of feedback loops, which enable information to survive within the network. Long short-term memory. LSTM is a type of RNN that is designed to overcome the vanishing gradient problem in training RNNs. It uses memory cells and gates to selectively read, write, and erase information. Neural networks applications. Face recognition. Neural networks analyze facial features to match and verify identities. They're widely used in security systems and social media. Accuracy improves with more data and training. They help automate identification in various applications. Image and video recognition. Neural networks identify objects, scenes, and actions in images and videos. Detects objects in real time. Deep learning allows recognition in real time. It's increasingly used in smartphones and cameras. Autonomous driving. Neural networks process data from sensors to navigate vehicles. They help make driving decisions based on the environment. Deep learning enhances safety by predicting potential hazards. These networks are crucial for fully autonomous cars. Natural language processing. NLP uses neural networks to understand and generate human language. It's used in translation, chatbots, and sentiment analysis. The technology aids in voice assistance and customer service. Neural networks improve text comprehension and generation. RNNs and transformers power language translation, chatbots, and sentiment analysis. Finance. Neural networks predict stock prices and market trends. They detect fraudulent activities and optimize financial strategies. Deep learning models analyze vast amounts of historical data. They're also used in credit scoring and risk assessment, predicting stock prices, fraud detection, and risk management. Medical image analysis. Neural networks analyze X-rays, MRIs, and CT scans for signs of disease. They help detect conditions like tumors and fractures. Deep learning models assist doctors in diagnosis with high accuracy. It's revolutionizing healthcare by aiding early detection. Gaming and autonomous systems. Neural networks power AI in video games, making NPCs more realistic. They also control robots and drones for autonomous operations. These systems learn from the environment to adapt to new challenges. Gaming AI becomes more immersive through neural networks. Neural networks enable real-time decision-making, enhancing user experience in video games and enabling autonomous systems like self-driving cars. Translate text. Neural networks help translate languages by understanding context and meaning. They enhance translation quality with deep learning techniques. Real-time translation is increasingly accessible with apps and services. Neural networks bridge communication barriers across languages. Recognize speech. Speech recognition systems use neural networks to understand spoken language. They convert speech to text in applications like virtual assistants. Accuracy improves as neural networks process diverse accents and languages. It's widely used in hands-free control devices. Read handwritten text. Neural networks are used to decipher handwritten notes and documents. They're critical in digitizing paper records and signatures. Deep learning models improve accuracy as they learn from different handwriting styles. This technology enhances data extraction and archival systems. Control robots. Neural networks enable robots to learn complex tasks autonomously. They adapt to their surroundings and make decisions in real time. These systems are used in manufacturing, healthcare, and research. Robotics is advancing thanks to deep learning and neural networks.